All right, so we want to find the volume of the solid obtained by rotating the region under the curve f of x equals radical x from 0 to 1 about the x-axis. All right, so let's write down what we have. We have f of x equals radical x. X is ranging between 0 and 1. And we're rotating about the x-axis. All right, so like any good math student, we're going to want to draw a picture first. Draw my xy plane. And here's radical x. All right, and it's bounded between 0 and 1. All right, so then there's my region. So there's my region right there. All that. Okay. So we're going to revolve around the x-axis. And by doing this, I'm going to get a solid. Right, so I revolve this 2D region, and that gives me a 3D shape. Let's draw our solid. Okay, so draw the xy axis again. Draw radical x. And now this is being rotated around the x-axis, so we're going to have like, I draw this mirror image kind of radical x below here. And I'm revolving, so I have this circular action here. Okay, so you can see here's my solid. It looks kind of like a gumdrop. All right, so now to calculate this solid, we're going to calculate the volume of this solid. We're going to use the disk method. Okay, and recall that the formula for the disk method is given by v equals pi, the integral from a to b of r of x squared dx. All right, so in order to evaluate this integral, we need to know what a, b, and r of x is. All right, now a and b, those are the x values that my region is bounded between. Now, they're x values because this is the integral with respect to x. I'm taking the integral dx, right? So a and b have to be x values, and they're the x values that bound my region. So those are 0 and 1, right? Now r of x, that's the radius. So if you recall the derivation of the disk method, r of x is the radius of the approximating disks. All right, so we can see the radius of my solid at the base is like this, right? But over here, the radius, that's a little shorter. Okay, so that's why it's r of x, right? Because the radius depends on x. Depending on where I am on the x-axis, my radius is going to be a different value. All right, so I need to figure out what this value is, and it's going to be a function, some function of x. That's why it's written r of x. Okay, so to figure out what r of x is, this is pretty easy here because in this example, just keep in mind that the distance between the x-axis and the curve, that value is just the value of the function itself. So r of x is really just radical x. All right. So now we're ready to throw everything into the formula. All right. So in other words, we want to substitute. So this volume is going to be pi, and we said a and b are 0 to 1. R of x, we have radical x squared dx. All right, so I'll leave it to you to evaluate that integral, and you should get pi over 2.